Good morning everyone. Welcome to the online CET, NEET, JEE classes. Students, in this video I am going to discuss some multiple choice questions with answers on the inorganic chapter D and F block elements. Here I select some questions from the given material. So observe questions one by one carefully. First question: which of the following is the most suitable description of transition elements? Observe the questions and given options carefully. First question is: which of the following is the most suitable description of transition elements? Students, first option A, low melting points. Option B, no catalytic activity. Option C, shows variable oxidation states. Option D, exhibit inert wear effect. When we observe the given options, the detailed knowledge of transition elements is very important now. Transition elements shows variable oxidation state. They have electrons in d orbitals. We know this point. Students, transition elements have higher enthalpy of atomization because of the involvement of greater number of valence electrons in the bonding. So their melting point are higher than transition elements. Transition element shows catalytic activity due to their variable oxidation state. Energy of Ns and N-1d orbitals are nearly same, and the electrons of Ns and N-1d orbitals can take part in a bonding, and only heavier p block element shows inert wear effect, not d block elements. Therefore, option C is right description for transition elements among the given options. What is that? Transition elements shows variable oxidation states. Therefore, option C is the right answer. Option C is the right answer. Option C is the correct answer. Yes, next question, question number 3. The stability of a particular oxidation state. The stability of particular oxidation state of a metal in aqueous solution is determined by. The stability of particular oxidation state of a metal in aqueous solution. Remember, in aqueous solution it is determined by option A, enthalpy of sublimation of a metal. Option B, ionization energy. Option C, enthalpy of hydration of the metal ion. Option D, all of these. Observe the given options carefully. If metal, if it lost an electrons, then it gets that much of charge. If metal M, it lost one electron, then metal gets positive charge, M plus. If it lost two electrons, then we write M2 plus. Remember, when you observe this question, metal, when it lost electron, it gets a positive charge. This changes involves sublimation, ionization as well as hydration. Students, the stability of particular oxidation state of a metal, the stability of particular oxidation state of a metal in aqueous solution is determined thermodynamically. Enthalpy of sublimation or heat of sublimation is the heat required to change 1 mole of a substance from solid state to a gaseous state at given temperature and pressure. When we put in the aqueous solution where enthalpy of hydration of the metal ion occurs, if we know this concept, the correct answer for this question is all the given options A, B, C are correct. Therefore, option D, all of these is the right answer. Therefore, the correct answer for this second question is option D. Option D is the right answer. Next, question number 5, students. Read the questions carefully. The first ionization energies of the elements of the first transition series, titanium to copper. The first ionization energies of the elements of the first transition series, titanium to copper. Option A, increase as the atomic number increases. Option B, decreases as the atomic number increases. Option C, do not show any change as the addition of electron takes place in the inner n-1d orbitals. And option D, increases from titanium to manganese and then decrease from Mn to Cu, means manganese to copper. Yes, which one is the right answer for this question? Here one word, ionization energy of the elements of first transition series is used. Remember, students, ionization energy of 3D series increases with increase in atomic number. Remember this one. Ionization energy of 3D series increases with increase in atomic number due to increase in nuclear charge and decrease in atomic size. Due to increase in nuclear charge and decrease in atomic size. Students, in case of transition metals, the addition of increasing number of d electrons provides a shielding or screening effect. Thus, shields the increasing nuclear charge and the expansion of d orbitals then to opposite each other. On account of these two opposing effect, the ionization energy increases rather slowly on moving along the period. Ionization energy increases rather slowly on moving along the period. Therefore, the correct answer for the given question is option B. The first ionization energies of the element, option A. The first ionization energies of the element of the first transition series increases as the atomic number increases. Option A is the right answer for this question. Option A. Yes, next question. Question number 7. Correct electronic configuration of chromium. Here Z equal to 24 means, I think we know, atomic number is 24. As correct electronic configuration of chromium Z equal to 24 is option A 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s1. Option B 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Option C 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Option D 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Yes, which one is the right answer? One of the easiest question. Students, we already know atomic number of chromium equal to 24. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This type of electronic configuration is because of exactly half filled d orbitals gives the extra stability to an atom. Hence, option B is the correct answer for this question. What is the question, students? Correct electronic configuration of chromium is S2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Option B is the right answer. Option B is the right answer. Next, question number 8. Question number 8. Transition elements. The question is like transition elements. Option A have low melting point. Option B exhibit variable oxidation state. Option C do not form colored ions. Option D they shows inert fair effect. Transition elements. Students, in transition metals of d electrons also take part in bonding, so they show variable oxidation state. This one is the very important point related to transition elements. Remember, these elements means transition elements shows variable oxidation state because their valence electrons in two different sets of orbitals, that is n-1d and ns. the energy difference between these orbitals is very less. Remember, this is very important. The energy difference between n-1d and ns is very less. So, both the energy levels can be used for bond formation. Therefore, the transition elements have variable oxidation state property. As which option is related to transition elements here? Option B, they exhibit variable oxidation state, is the right answer. Option B is right one. Yes, next question number 10, students. The volatile metal is option A Fe, option B Zn, option C Cu, and option D Ag. Iron, zinc, copper and silver. Among the given options, which one is the volatile metal? Remember, volatile metal. When we observe the given options, here option B, they given zinc. Remember, zinc is an example for volatile metal. Among the given options, zinc is most volatile. Remember, group 12 elements are volatile in nature. Which group elements? Group 12 elements are volatile in nature. All other transition series elements have incomplete D or S. Both orbitals, they can form covalent as well as ionic bond. While Zn means zinc, here D and S orbitals are completely filled, so they can form only metallic bonds. Since the metallic bond is weak, it makes zinc volatile. If we know this concept, the correct answer for this question is option B. Zinc is one of the volatile metal, students. Which one is the right answer? Option B is correct answer. Next, question number 12. Observe the questions and given options carefully. The common oxidation state of titanium are. The common oxidation state of Ti means titanium are option A +2 and +3, option B +3 and +4, option C -3 and -4, option D +2, +3 and +4. Observe the given options carefully. Which one is right answer? Students, the minimum oxidation state in transition metal is equal to the number of electrons in the cell, and the maximum oxidation state is equal to the sum of the 4s and 3d electrons. Remember, this one is very important. It is helpful point. The minimum oxidation state in transition metal is equal to the number of electrons in 4s shell. Remember, The minimum oxidation state in transition metal is equal to the number of electrons in 4s cell, and the maximum oxidation state is equal to the sum of the 4s and 3d electrons. If we take titanium, you know its electronic configuration simply written as argon 3d2 4s2, 3d2 4s2. Here minimum oxidation state is +2 and maximum oxidation state is +4. Thus the common oxidation state of titanium are +2, +3 and +4. Yes. Now, which one is the right answer for this question? The common oxidation state of titanium are option D, +2, +3 and +4. Therefore, option D is the right answer. Option D is the right answer. Next, question number 13. Which pair of elements with the given atomic numbers? Which pair of elements with the given atomic numbers is expected to have similar properties? Which pair of elements with the given atomic numbers is expected to have similar properties? Here some atomic number combinations are given. Observe carefully. Option A 40 and 72. Option B 20 and 36. Option C 10 and 28. Option D 11 and 12. Among these given options, which pair of elements is expected to have similar properties? Yes, students, option A, here the given 40 and 72. Atomic number 40 element is Zr, means zirconium, and 72 atomic number element is HF, means hafnium. Both the elements, means zirconium and hafnium, they have similar properties as they belongs to same group and have same valence cell electronic configuration. Zirconium and hafnium, they have similar properties. They show similar properties. We know one concept, that is lanthanoid contraction. Because of that lanthanoid contraction, zirconium and hafnium shows similar properties. Therefore, the correct answer for 13th question is option A. 40 and 72 atomic number containing elements having similar properties. Next, question number 15, means 15. The oxidation state of chromium in the final product formed by the reaction between Ki, means potassium iodide, and acidified potassium dichromate solution is. The oxidation state of chromium in the final product. Oxidation state of chromium in the final product formed by the reaction between Ki and acidified potassium dichromate solution is option A +3, option B +2, option C +6 and option D +4. Write the required equation for this question. Here I write the reaction like chromium means Cr2O7 2 minus plus 6I minus plus 14H plus. See the reactants, Cr2O7 2 minus plus 6I minus and 14H plus. The combination of all these three gives the product like 3 moles of iodine, 7 moles of water and 2 moles of Cr3 plus ion. In this reaction, the oxidation state of chromium in the final product side is 3 plus. In the product, the oxidation state of chromium is 3 plus. Therefore, option A plus 3 is the right answer for this question. Option A is the right answer. As next question. Question number 16. Chloro compounds of vanadium has only spin magnetic moment of 1.73 Bohr magneton. This vanadium chloride has the formula. Let's carefully observe the question. Chloro compound of vanadium has only spin magnetic moment of 1.73 Bohr magneton. Already they given the spin magnetic moment value means mu equal to 1.73 Bohr magneton. This vanadium chloride has the formula, as they want to formula of that particular vanadium chloride. As we know how to calculate the magnetic moment, used one formula, mu equal to under root of n into n plus 2, where n is the number of unpaired electrons, but they given already mu value means under root of n into n plus 2 equal to how much? 1.73. Write all the steps clearly. If the value of n under root of n into n plus 2 equal to 1.73, definitely the value of n equal to 1 means number of unpaired electrons here, that is 1. Students, electronic configuration of vanadium is how you write this? Argon 4s2 3d3, right? Argon 3d3 4s2. Therefore, it contains only one unpaired electron. Only one unpaired electron. It has to be V4 plus, vanadium 4 plus, charge is 4 plus. Hence the formula of vanadium chloride is VCl4, vanadium tetrachloride, VCl4. Therefore, correct answer for this question is VCl4, option B. Option B is the right answer. Next question number, if you know more about the 16th question, see here. The spin magnetic moment is the magnetic moment generated by the spin of the electron, right? Remember, the spin magnetic moment is the magnetic moment generated by spin of an electron. The elementary spin in an electron is half fermion. The commonly used value to measure the magnetic moment is Bohr magneton. Students, in the given question, atomic number of vanadium is 23 its electronic configuration is argon 3d34s2. Only one unpaired electron is present here. 4 Cl atoms can only combine with vanadium ion. Therefore, formula of the compound is VCl4. Right? Yes. Move to the next question. Question number 18. The aqueous solution containing which one of the following ions will be colorless? See the questions carefully. The aqueous solution containing which one of the following ions will be colorless? In the bracket they given atomic number of scandium equal to 21, Fe means iron equal to 26, titanium 22, manganese 25. The aqueous solution containing which one of the following ions will be colorless? Yes. To know the color property, must and should we calculate the number of unpaired electrons present in a particular ion. Right? See first option A, Sc3+, scandium 3+ ion. Students, when we write the electronic configuration of scandium 3+, then it ends with 3d0 and 4s0. 3d0, 4s0 means there is no unpaired electron. Sc3+, it contains 0 number of unpaired electrons. Next, when you observe the option B, Fe2+, its electronic configuration of Fe2+, it is 3d6 4s0. Write this point, 3d6 4s0, Fe2+. Then we fill the 6d electrons in d orbitals. It contains 4 unpaired electrons. Right? First you write the single electron, therefore 5 electrons filled first and 6th electron takes place in the first d orbital. Therefore it contains 4 unpaired electrons. Fe2+, it contains how many unpaired electrons? 4. Next option C, titanium 3+, Ti3+. Its electronic configuration ends with 3d1 4s0. 3d1 means it contains only one unpaired electron. Next, Mn2+, its electronic configuration is 3d5 4s0. 3d5 4s0 means it contains 5 unpaired electrons. Students, when we observe the number of unpaired electrons in the given options ions, in scandium 3+, there is no unpaired electrons. So the aqueous solution of Sc3+ will be colorless. Right? Therefore, the correct answer for this question is option A. Option A, scandium 3+. It is colorless. Next, question number 19. Read the questions carefully with given options first. Zinc gives H2 gas with H2SO4 and HCl but not with HNO3 because, remember, zinc gives H2 gas. Zinc gives H2 gas with only H2SO4 and HCl but not with HNO3 because option A, zinc acts as an oxidizing agent when react with HNO3. Option B, HNO3 is weaker acid than H2SO4 and HCl. Option C, in electrochemical series, zinc is above hydrogen. Option D, NO3 minus ion is reduced in preference to hydronium ion. Think and carefully understand the given question first. Students, when you observe the given options, NO3 minus means nitrate ions are reduced by nascent hydrogen, because when one of the metal is react with HNO3 means nitric acid, metal nitrate is formed with the liberation of nascent hydrogen. Metal react with HNO3, metal nitrate is formed along with nascent hydrogen. That nascent hydrogen is again treated with nitric acid. It forms N2O. It forms N2O with liberation of 5 moles of water. 5 moles of water. Right, write the reaction carefully. When HNO3 is react with 8 moles of hydrogen, it forms nitrous oxide and 5 moles of H2O. Students, remember, nitric acid is a very strong oxidizing agent, and hence it leads to the addition of oxygen to another substance. When hydrogen is formed due to addition of nitric acid on zinc metal, it oxidizes hydrogen to water, and thus the reaction becomes, write the reaction, Zn plus 4HNO3 gives ZnNO3 twice, means zinc nitrate plus NO2 plus H2O. As which one is the correct answer for this question now? Option D, NO3 minus ion is reduced in preference to hydronium ion. Option D is the right answer. Option D. Yes, next question number 20, students. Among the transition elements, the element with the lowest melting point belongs to. Observe the question carefully. Among the transition elements, the element with the lowest melting point belongs to. Option A, group 3. Option B, group 11. Option C, group 6. Option D, group 12. Yes, which one is the correct answer? Students, zinc, cadmium, mercury with complete outermost D subcells have lowest melting point and belongs to group 12. Remember, zinc, cadmium and mercury with complete outermost D subcells have lowest melting point and belongs to group 12. Mercury has weakest interatomic interaction on account of number of unpaired electrons. Mercury has weakest interatomic interaction on account of number of unpaired electrons available for bonding. Therefore, these type of properties are shown by group 12 elements. Therefore, among the transition elements, the elements with lowest melting point belongs to group 12. Therefore, option D is the right answer. Next question number 22. Which of the following ions does not liberate hydrogen gas on reaction with dilute acids? Which of the following ions does not liberate hydrogen gas on reaction with dilute acids? As question number 22, the given options are option A Ti2 plus, option B V2 plus, option C Cr2 plus, option D Mn2 plus. Students, when we observe the electrode potential in presence of old titanium 2 plus, it is minus 0.37. V2 plus means vanadium 2 plus, it is minus 0.26. Cr2 plus, it is minus 0.41, and Mn2 plus, it is plus 1.57. Negative value of electrode potential E naught means negative value of E naught means these metals liberate hydrogen from dilute acid. Negative value of E naught means these metals liberate hydrogen from dilute acids. The comparison of electronegativities of the first row transition metals will provide the common answers as we go from left to right. The electronegativity increases, thus it is rather active metals. On the other hand, copper is much less reactive. Students, metal reactivity series is the series based on the reactivity of the metals. Remember, the more reactive metals are kept at the top of the series, followed by ones with the lower reactivity. The more reactive a metal will be, the more will be its tendency to lose electrons. If you know this concept well, the correct answer for 22 question is, the right answer for 22 is option D, Mn2 plus, because its E naught value is plus 1.57. Yes, next question number 24. Which one of the following species is stable in aqueous solution? Which one of the following species is stable in aqueous solution? Option A Cr2 plus, option B MnO4 2 minus, option C MnO4 3 minus, option D Cu plus. Yes, in MnO4 2 minus, manganese is in plus 6 oxidation state, which is having highest stability. Remember, in MnO4 2 minus, manganese is in plus 6 oxidation state, which is having highest stability. And in MnO4 2 minus, disproportionate in neutral or acidic solution. When we observe the reaction of 3 moles of MnO4 2 minus, when it is react with 4 moles of H plus, it gives 2 moles of MnO4 2 minus plus MnO2 plus 2H2O. Students, MnO4 3 minus, another option, MnO4 3 minus is unstable in aqueous solution, as plus 5 oxidation state of Mn is unstable. MnO4 2 minus is stable in aqueous solution, as plus 6 oxidation state of Mn is stable. Therefore, option B, MnO4 2 minus is correct answer for this question. Option B is the right answer. Next question number 27. Which transition metal has lowest density? Which transition metal has lowest density? Option A scandium, option B titanium, option C zinc, and option D lanthanum. Which transition metal has lowest density? Yes students, scandium is lightest transition element. It is the first element in the 3D transition series. Is it right? Yes, it is. Scandium, it is one of the first element in the 3D transition series. Among the transition elements, scandium has the lowest density. If you want to know the values of density of scandium density is 3.0 gram per cm cube. Remember, most of the transition elements has a density greater than 6 gram per cm cube, but scandium it has only 3.0 gram per cm cube. Therefore, the correct answer for the 29th question is option A. Sorry, 27th question answer is option A, scandium. Next question number 29. Titanium shows magnetic moment of 1.73 Bohr magneton in its compound. What is the oxidation number of titanium in the compound? Option A +1, option B +4, option C +3, option D +2. Yes, observe the given options carefully. We already know the formula to calculate the magnetic moment, that is mu equal to under root of n into n plus 2. Here already they given mu equal to 1.73, means it contains only one unpaired electron, because if you substitute the value of n equal to 1, then only you get the answer 1.73, right? Yes. Electronic configuration of titanium is argon 3d2 4s2. So it will lose 3 electrons to have one unpaired electron, and the oxidation state of titanium is +3. Therefore, the correct answer for this question is option C. Option C +3 is the right answer. Next question number 32. The atomic number of vanadium, chromium, manganese and iron are respectively 23, 24, 25 and 26. Which one of these may be expected to have the highest second ionization enthalpy? Options are given here. Option A vanadium, option B chromium, option C manganese, option D iron. Observe the question and given options once again carefully. Students, the atomic number of vanadium, chromium, manganese and iron are respectively 23, 24, 25 and 26 they given. Chromium may be expected to have the highest second ionization energy. The electronic configuration of chromium is argon. Write this point. Electronic configuration of chromium is argon 3d5 4s1. It lost one electron to form argon 3d5 4s0, in which 3d subshell is half filled and stable. When another electron is removed, it is removed from half filled 3d subshell and the stability of 3d subshell is lost. This required high energy. Therefore, the correct answer for this question is option B chromium. this one is expected to have the highest second ionization enthalpy. Option B is the right answer. Next question number 35. The maximum oxidation state shown by vanadium Z equal to 23, chromium Z equal to 24, cobalt Z means atomic number 27, scandium atomic number 21 respectively. Question is the maximum oxidation state shown by among vanadium, chromium, cobalt and scandium respectively. Option A +5 +6 +2 +3. Option B +3 +4 +5 +2. Option C +5 +3 +2 +1. Option D +4 in each case. The correct answer for this question. Students, electronic configuration of vanadium is argon 3d34s2 and thus maximum 5 electrons participate in the bonding, right? Electronic configuration of chromium is argon 3d54s1. Listen carefully. Electronic configuration of chromium is argon 3d54s1. Now maximum 6 electrons participate in the bonding. Electronic configuration of cobalt is argon 3d74s2. In octahedral splitting, the presence of ligands half-filled T2G has higher crystal field stabilization energy, higher CFSE, and thus +3 oxidation state is most stable. Electronic configuration of scandium is argon 3d14s2 and thus maximum 3 electrons participate in the bonding, right? Therefore, when we observe the given options, the correct matched oxidation state shown by vanadium, chromium, cobalt and scandium is option A +5 +6 +2 and +3. Therefore option A is right answer. Next question number 37. Group 12 elements are included in D block and have configuration N-1 D10 NS2. Hence, this question is related to group 12 elements. Group 12 elements are included in D block and have configuration N-1 D10 NS2. Hence, option A, they are high melting point solids. Option B, they must form colored compounds. Option C, they and their compounds are paramagnetic. Option D, they and their compounds are diamagnetic. Which one is the right answer? Students, metals of 12th group and their ions means M2+ ions do not have any unpaired electrons, right? Therefore, when you observe clearly the given options, option D, they and their compounds are diamagnetic. Diamagnetic means they contain paired electrons. There is no unpaired electrons. Yes, therefore option D is the right answer. Next question number 40. Number of unpaired electrons in Ni2+, where atomic number Z equal to 28 is. Number of unpaired electrons in Ni2+ ion. Options are given Option A 4, option B 2, option C 6, option D 8. Yes, which one is the right answer? Students, first we write atomic number of nickel. It is already given, that is 28. Write the ground state electronic configuration. Ground state electronic configuration of nickel is 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. Yes, remove the 2 electrons from 4s orbital now. Then electronic configuration of Ni2 plus ion is 1s2, 2s2, 2p6, 3s2, 3p6, 3d8. Instead of 4s2, I write now only 4s0. Yes, when we fill in the 3d orbitals 8 electrons, now 2 unpaired electrons are present here. Remember, nickel has 2 unpaired electrons in 3d subcell. When nickel ionizes to the +2 state, it loses the 2 electrons in the 4s. So there are still 2 unpaired electrons in nickel 2+. Therefore, the right answer for 40th question is option B. Option B 2 is the right answer because it contains 2 unpaired electrons. Next question number 44. From a solution of copper sulfate, the metal used to recover copper is. From a solution of copper sulfate, the metal used to recover copper is option A sodium, option B silver, option C mercury, and option D iron. It is one of the direct theoretical question. Students, iron means Fe can be used to recover copper from copper sulfate solution. Remember the concept. Answer D. Fe is the means iron is used to recover the copper from its copper sulfate. Option D. Fe is the right answer. Next question number 46. Among the following pairs of the ions, lower oxidation state in aqueous solution is more stable than the other in. Among the following pairs of ions, lower oxidation state in aqueous solution is more stable than other in. Observe the given options very carefully. Ti plus Ti3 plus given, Cu plus Cu2 plus given, Cr2 plus Cr3 plus they given. In option D they given V2 plus VO2 plus. Yes, think the answer for this question. Very important. Students, titanium means Ti plus does not exist. Cu plus does not dissolve in water. Remember all these points. Ti plus, it does not exist. Cu plus does not dissolve in water. Cr2 plus is less stable than Cr3 plus because both do exist in aqueous solution. Oxidation state of vanadium in VO2 plus is +6. Remember, Ti plus ions are more stable than Ti3 plus. Remember, Ti plus ions are more stable than Ti3 plus. Ti3 plus ions change to Ti plus ions, thereby acting as a oxidizing agents. In solutions, hydration enthalpy of ions also affect their stability. So based upon both fact is that electronic configuration and hydration enthalpy, Ti plus is more stable than Ti3 plus in solution, while other two cases higher oxidation state ions are more stable. Therefore, option D, V2 plus and VO2 plus is right answer for this question. Next question number 55. Iron is obtained on a large scale from Fe2O3 by. Iron is obtained in a large scale from Fe2O3 by option A, reduction with Al, option B, smelting with carbon, option C, calcination, option D, water gas. Yes, which one is the right answer for this question? Remember students, Fe2O3 is the chemical formula for ferric oxide. When 2 unit of ferric oxide and 3 unit of carbon is mixed, remember, when 2 unit of ferric oxide and 3 unit of carbon is mixed in solid state at high temperature, then the end product of the chemical reaction is 3 unit of carbon dioxide in gaseous state and 4 units of iron in liquid state. This reaction is also known as smelting with carbon. Therefore, among the given options, in the option B, they given smelting with carbon. This one is the right answer for the given question. Iron is obtained on a large scale from Fe2O3 by smelting with carbon process. Therefore, option B is right one. Next, question number 59. Which of the following is used to purgative in medicine? Which of the following is used as a purgative in medicine? Option A, zinc chloride, mercury chloride, mercurous chloride. Observe the given options carefully. They given ZnCl2, HgCl2 and Hg2Cl2. Option D, zinc sulfate 7H2O. Yes, which one is the right answer for this question? Students, the substance which loosen the stools and increase the bowel movement are known as purgative. Remember, the substance which loosen the stools and increase the bowel movement are known as purgatives. Another name for purgative is laxative. Mercurous chloride Hg2Cl2, mercurous chloride Hg2Cl2 is used as a purgative in the medicines. Yes, which one is the right answer now? Option C, mercurous Hg2Cl2 is the right answer for this question. Yes. Next, question number 62. Number 62. Iron once dipped in a concentrated H2SO4 does not displace copper from copper sulfate solution because iron once dipped in a concentrated H2SO4 does not displace copper from copper sulfate solution because option A, it is less reactive than copper, option B, a layer of sulfate is deposited on it, option C, an inert layer of iron oxide is deposited on it, and option D, all valence electrons of iron are consumed. As when we observe carefully the given options, We know one point. Iron, once dipped in a concentrated H2SO4, it does not displace copper from copper sulfate solution because it is less reactive than copper. A layer of sulfate is deposited on it. An inert layer of iron oxide is deposited on it. Therefore, option C is the right answer. Option C. Next question, number 64. Mercury is the only metal which is liquid at 0 degrees Celsius. This is due to its. Mercury is the only metal which is liquid at 0 degrees Celsius. This is due to its. Option A, very high ionization energy and weakly metallic bond. Option B, low ionization potential. Option C, high atomic weight. Option D, high vapor pressure. Mercury is the only metal which is liquid at 0 degrees Celsius. This is due to its. Remember students, it is due to very high ionization energy which results in weak metallic bonding. Due to very high ionization energy, mercury atoms do not share electrons with each other easily. Due to this, mercury has weak interatomic metallic bond. Due to very high ionization energy, mercury atoms do not share electrons with each other easily. Due to this, mercury has weak interatomic metallic bond. Therefore, correct answer for this question is option A. Next question, number 66. Which of the following is the correct formula for a compound of scandium and oxygen? Which of the following is the correct formula for a compound of scandium and oxygen? Option A, Sc2O. Option B, SCO. Option C, Sc3O2. And option D, Sc2O3. Yes, students, when we observe the given options, here the given option C, Sc3O2. We know scandium oxidation state is +3 and oxygen its oxidation state is -2. So correct formula, cross multiplication, gives Sc2O3, scandium 3 oxide. As correct answer for this question is option C. Next question, number 67. Which of the following is called Wilkinson's catalyst? Which of the following is called Wilkinson's catalyst? Yes, one of the theoretical point you must and should remember. Wilkinson catalyst is RHCl PPH3. It is one of the red violet color complex and has square planar structure. It is used for selective hydrogenation of organic molecules at room temperature and pressure. Students, the other options, they given TiCl4, C2H53, Al means titanium tetrachloride, and triethyl aluminum. It is one of the Ziegler-Natta catalyst. C2H54Pb is an anti-knocking agent, and another one option they given cisplatin. It is used as an anti-cancer agent, right? But Wilkinson catalyst is option A. Option A is the right answer. Next, question number 71. Which of the comparison regarding zinc, cadmium, mercury is incorrect? Options are given. Observe the given options also. Zinc chloride is ionic, whereas cadmium chloride and mercury chloride are covalent. Option 2. Zinc and cadmium dissolve in dilute acid, liberating H2, but Hg cannot. Third point, zinc and cadmium forming with precipitate of zinc hydroxide and cadmium hydroxide, but Hg forms colored precipitate of mercuric hydroxide. Fourth point, all form A2 2+ type ion. Students, mercury chloride, when we observe the given points, mercury chloride is covalent in nature, whereas zinc chloride and cadmium chloride are ionic in nature. Thus, statement first one is incorrect. Less electropositive mercury cannot displace hydrogen from acids. Remember, less electropositive mercury cannot displace hydrogen from acids. More electropositive zinc and cadmium can displace hydrogen from acids. Therefore, statement 2 is correct one. Mercury does not form hydrogen or peroxides, whereas zinc and cadmium form hydroxides and peroxides. Therefore, statement 3 is incorrect. Mercury forms Hg2 2+, which is unique as no other ion exists as such. Zinc and cadmium does not form A2 2+. The statement 4 is incorrect. Zinc and cadmium does not form A2 2+ ion, remember. Therefore, among the given options, option 1, 3 and 4 are incorrect. Therefore, option B is the right answer. Option B is the right answer. Next, question number 74. When concentrated HCl is added to an aqueous solution of COCl2, its color changes from reddish pink to deep blue. Which complex ion gives blue color in this reaction? When concentrated HCl is added to an aqueous solution of COCl2, its color changes from reddish pink to deep blue. Which complex ion gives blue color in this reaction? Observe the given options carefully. Aqueous solution of COCl2 cobalt chloride contains cobalt 6H2O, means hexa aqua cobalt 2+, which is pinkish in color. So option D is incorrect. Remember, aqueous solution of COCl2 contains hexa aqua cobalt 2+, which is pinkish in color. So option D is incorrect. Reduction potential of CO3+ changes to CO2+ is high. So option B is incorrect. CO2+ does not oxidizes easily to CO3+. It is general case that symmetrical substituted octahedral complexes are less deeper in color than tetrahedral complexes. So, cobalt tetrachloride COCl4 2- is deep blue in color. Therefore, the correct answer for this question is option A. option A is the right answer. Next question number 79. Colorless solutions of the following 4 salts are placed separately in 4 different test tubes and a strip of copper is dipped in each one of these. Which solution will turn blue? Colorless solutions of the following 4 salts are placed separately in 4 different test tubes and a strip of copper is dipped in each one of these. Which solution will turn blue? Option A, KNO3 means potassium nitrate, silver nitrate, HNO3, zinc nitrate, ZnNO3 twice, and zinc sulfate. Student, first you write one reaction, Cu plus 2AgNO3 means 2 moles of AgNO3. It gives CuNO3 twice copper nitrate plus of 2 moles of Ag and Cu2 plus ion. When Cu is react with AgNO3 means silver nitrate will give blue solution. Cu2 plus is below in ECS means electrochemical series. Copper is below ECS than potassium and zinc, hence no reaction will be occur with them. AgNO3 will turn the copper solution blue. Blue color is due to the formation of Cu2 plus ions. Silver comes above copper in the electrochemical series. Zinc and potassium are placed below copper in electrochemical series. Thus, copper can displace silver ions from its salt solution, but potassium and zinc cannot displace silver ions from its salt solutions. Therefore, right answer for the 79th question is option B, silver nitrate. Next question number 82. Among the following, the compound that is both paramagnetic and colored is option A, KMnO4, option B, CuF2, and option C, K2Cr2O7, and option D, all are colored. Yes, observe once again the given question with options. When you observe the given options, in that option B, that is CuF2, copper difluoride, it is both paramagnetic and colored. Remember, in case of CuF2, copper is in in case of CuF2, Cu is in T2 oxidation state. In CuF2, copper oxidation state is +2 and its electronic configuration is argon 4s0 3d9. 4s0 3d9, which signifies that it has one unpaired electron. Due to the presence of this unpaired electron in copper, CuF2 is showing paramagnetic behavior as well as color. Therefore, the correct answer for this question is CuF2, option B. Okay, students, in next video we discuss another multiple choice questions with answers. Thank you.